Oh, is it recording? Yes, we're live. Good. Okay. So, you can put it on a graphics calculator, and that's not a bad way to do it, but we're just going to use Desmos, because Desmos makes it the easiest, right? So we're going to just graph this, and I already know what it looks like, and you should know what it looks like. I don't really need a calculator, but if you want to put on Desmos, you can, right? We can go straight to Desmos, and I can just go on x squared minus 4, and I'm going to change the shape, and there it is. It looks like that. We know it goes through 4. Got my pen. Goes through 4, and it goes through 2 and negative 2. We know that from last chapter and geometry, right? Okay, there it is. So it talks about a minimum value. Minimum value is vertex, which is at 0, negative 4. Okay? That was easy, right? Very easy. Okay? Let's look at the next one. Okay? So if we let Desmos do the work for us, pretty easy lesson, right? So x cubed, right? And we're going to go subtract 9x. It looks like that. So x cubed's got even more bumps, right? So it's more curvy because you've increased its degree. Okay, that's the degree right there, okay? 1, 2, 3, 1, 2, 3. That's going to look like this. And we don't have to have it perfect. I just need the shape, okay? There it is. Now the cool part about Desmos, oh my gosh, it makes it so easy. I love Desmos, because you can just tap on it. Well, max, it's called a local max, and I'll explain why. That has to be a local max because, and I'll wait till you guys are looking at the graph. Go ahead and catch up. That's called a local max because watch my pen. Watch my pen. It's even higher, right? The graph keeps going. So, I mean, obviously, this is not the total max, because total max goes out to infinity, but it's a local max because it's at the top of a hill. Desmos is going to get it for me, so you just tap on it. I love it. Negative 1.7, so we'll round. Then there's tenth, negative 1.7, comma, 10.4. That's the local max. And the local min, which is down here, right? Same thing. I mean, just tap on it. And there it is. Okay, it's 1.7 and a negative 10.4. It's symmetrical, isn't it? Thumbs up. Let me just talk about the top of the hill, bottom of the hill. Easy, right? Okay, turn the page. Okay, now let's go ahead and sketch this one. Just plain old x cubed. So x cubed looks like this, okay? That's called an inflection point. Let's go ahead and sketch that. And we don't have to have a perfect bit. As it goes up, it curves like it's going to go down. It curves like it's going to go down, and then it changes its mind and goes up, okay? That is called an inflection point. And they talk about that a lot. That word is talked a lot in business. They talk about the inflection point. That word is in the news all the time. Oh, we've reached an inflection point. Have you ever heard that in the news? We've reached an inflection point. Well, if you're a business, think about this. You got great growth, good growth, and all of a sudden you start to slow down. You're like, oh no, this is slowing down. We're going to be in trouble. And then maybe you do something crazy, like you hire Francisco as the manager, right? You say, hey, dude, we need you to shake things up. And so you hire Francisco, and he says, hey, I'm shaking things up. And thanks to you, the business changes. That's an inflection point. Oftentimes it means that maybe they invest in some capital. As a business, they do something different to make their business grow, okay? So my inflection point's at 0, 0, okay? All right, number 4, let's graph number 4, okay? So I'm going to go x to the 4th. minus 3x squared minus 5. Okay. All right. Looks like a big W, doesn't it? So I know that's at negative 5. 1, 2, 3, 4, 5. And I don't have to have these perfect, but it looks like it is about 2. I just want the shape, right? Just want the shape. Negative 1.0. Oh, it goes all the way down to 7. Okay, all right. Okay, so right about here. There, and 1, 2, 3, 4, 5. So it's going to come down like this. It's going to do this kind of thing. Back up, right? Again, it doesn't have to be perfect. What I'm looking for is the shape, right? And the shape looks like that because it's next to the fourth, okay? So the degree is 4. Okay. So then, if I want the max and min, so it's got two minimums. It's got a minimum here and a minimum there, right? It's got two minimums. Love Desmos because I can just tap on it and get my minimum. So when I tap on that one, I got about a negative 1.2 comma negative 7.3. And I tap on the other side, I just get a positive 1.2 and a negative 7.3. I'm just letting my calculator do the work for me, right? And then in a second I'll tap on the max. Right? Negative 0, negative 5. So my max is at 0, negative 5. I mean, it's pretty easy, especially with Desmos. You guys agree? Okay, and I'll wait for you, and we'll do number 5. I'm going to type number 5 in while I'm waiting. X to the 5th. 3x cubed. And then plus 2, right? All right. Well, look at that weird graph. It's got all sorts of bumps and stuff in it, doesn't it? So every time you add a term, when I mean a term, every time I add a term, it gets more bumpy, doesn't it? So this one looks like this. And I don't have to have a perfect. I just want to, because I'm only looking at end behavior, but it looks like negative 1, 2, and this is at 2. I know that's at 2, and then so it does this weird thing here. Let's see if I can draw it pretty well. Okay, here it comes up. Just going to go and do a little thing like this, and then right about here, it does a weird little bumpy thing, right? And it goes back down and does a little thing like that, okay? I don't know if you guys can see that on your phone or not, but that's what my phone shows me, right? So that's another inflection point, isn't it? See how it changes right there? That's another inflection point. That's a max, and that's a min, right? You guys see the little inflection point? So that is an inflection point there. It's right there. That's a min. That's a max, okay? Now, but that wasn't what I was asking. I want to talk about end behavior, okay? So end behavior. That's the last thing I want to talk about, and then we'll look at your journal, okay? So end behaviors talk about what happens in the end. In the end, as x heads to infinity. End behavior, okay? End behaviors. Okay, so I want you both to watch. Okay, just watch. So as x heads to infinity, what's the graph doing? As x gets bigger and bigger, what's the graph doing? It's going off to also infinity, isn't it? So as x heads to infinity, then y is also heading to positive infinity, because y is going up, 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 up to positive infinity, right? So as x gets bigger, bigger, and bigger, the graph gets bigger and bigger, okay? Now, end behavior on this side, on the other end, is this. As x goes to negative infinity, right? So as x goes to negative infinity, the y is going down, right? Down, 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 down. The y value is going to negative infinity, okay? That's end behavior. What's going on in the end? Where is it going to? Is it going to infinity or negative infinity, okay? All right, now, one more thing. Let's take a look at, let's go back to our journals, okay? And I want to talk specifically about what a polynomial is, okay? So let's add some notes here. What is a polynomial, okay? And we're going to write this. It's an expression with whole number exponents. Okay? And the degree. I want to ask about the degree. Okay? So an expression with whole number exponents. Am I going too fast? Francisco, how am I doing? Okay? Now the degree is the biggest exponent. Biggest exponent. So I'm going to real quickly, I just want to go and look at our homework. You guys looking at number 1? Degree 4. This polynomial has degree 4. Degree 4. It's not in order. I wish it was in order. I would rewrite it in order. Normally I would rewrite this in order and put this one first. Like I'd go, okay. I like it in order. Negative 3x to the 4th plus 2x squared plus 6x plus 1. That's what we call it in order, right? With the biggest to the smallest. And the degree is 3. Oh, degree is 4. Come on, it's Friday. My goodness. Degree is 4 because that's the biggest exponent, okay? Now that's not hard, right? The degree, biggest exponent, okay? Now this thing called the leading coefficient, okay? Once I write it in order, descending order, biggest exponent, next. So it has to do with the exponents. Then the leading coefficient is the number in the front. It'd be the negative 3. So the leading coefficient, once you rewrite it and get everything in order, x to the 4th, all the way down, then the leading coefficient is the number in front. It's just the number in front. That'd be negative 3, okay? Now they have names, okay? I'm going to slide my book over and give you names when you're ready, okay? They have names. They have names, okay? So let's write the names down, okay? Names. One term. They have names. It has one term. It's called a monomial. Monomial. If it has two terms, it's called a binomial. Like a bicycle. Mi bicicleta. Francisco, that took me a long time to be able to say that. It did. I had to work on that one. But I love my bicycle, so I worked at it. 3 terms. It's a trinomial. Okay. And then beyond that, it's like, okay, I'll let you write this down. Then just listen. So we could say, and don't write this down, we could say, oh, a quadnomial, then a pentanomial, then a hexanomial, then a septinomial, then a octanomial, then a not. Are you kidding me? Anything more than three terms, we just call it a polynomial, okay? Which means many, okay? Polynomial, which means many, okay? Okay, so I go back to my problem. There's 1, 2, 3, 4 terms, right? I do not want to call it a quadrinomial. Let's just call it a polynomial. It's got lots, right? So we'll call it polynomial, okay? Polynomial. So then I'm just going to talk about the next ones, and you guys can do this on your homework, but I'll wait for you, okay? I'm going to talk about it. You guys can do it. So number 2, degree 3. You guys agree? Degree 3. It has 1, 2, 3 terms. Oh, no, wait a minute. This is not a polynomial. Uh-oh. You know why this is not a polynomial? Oh, my goodness. This is not. It's because of that right there. That's like a 7x to the negative 1, and that is not a whole number. So that's not a polynomial, right? Tricky. Almost tricked me, huh? Okay, let's look at number 3. How many terms? 2 terms, so this is called a binomial. It's degree 1. So this one's degree 1, even though it's an invisible. This one's degree 1. And it's a binomial. Its leading coefficient is the square root of 15. Okay. Number 4, it's not written in order. It's out of order, so I'm going to rewrite it. I'm going to put the negative 2x first, then plus my 3x, then minus my 2 squared roots of 3, okay? So I like to write it in order, what I call descending order. The degree is 2, right? Degree is 2 because of the biggest exponent, and it's got 1, 2, 3 terms. It's a trinomial. My leading coefficient is the negative 2, okay? I'll let you guys finish that up. Okay, I want to make sure I show you guys the last couple. Now, you can borrow my calculator in class, that's no problem, but number 5, and I'll wait for you, x equals 2. So all we're going to do is plug it in. So we're going to write this. That's the question. We're going to plug in 2. So I'm going to write h of 2. h of 2 means, what's the answer? Plug in 2 equals negative 2 cubed minus 2 times 2 squared minus 3 times 2 plus 4. Okay, so just plug 2 in for every x, right? And then I like to use my calculator because it just is so much easier on a calculator. So, because I can put the whole thing into my calculator. Watch me do it. I'm just going to go like this. I'm going to go negative parentheses because I'm putting it in 2 to the 3rd power. And then I'm going to go subtract 2, and I'm plugging in 2 squared, right? I'm going to go minus 3 times 2 plus 4. So let the calculator do the work. I'm plugging it in. Boom, answer, negative 18. And that is the point, okay, so negative 18, okay? Okay, that's all I have. I'm going to let you guys finish it up. And I'll load this up for everybody else, okay? What do you think?